car, right, upon graduating. Okay, that is simple interest. Now let's move on to compound interest. Okay? And we start off with a single amount scenario. Okay? Now, to put it simply, okay, compound interest is basically interest calculated, okay, on principal, but the difference now is that you add on to the interest charged or received from the last time period. Okay? So this new interest is added to the principal plus interest amount and becomes the new principal for the next interest period, so on and so forth. Hence the term compounded, okay? Because interest is compounded, okay? Carried forward from one period to the other. Okay? In the simple interest example earlier, interest is not compounded. Okay? So I provide you with this table for you to differentiate between the simple interest and compound interest. In simple interest, notice that the interest calculation in each period is based only on the original principal of the 100 ringgit. So therefore, after 5 years, the total interest is 50 ringgit, the accumulated interest. But in the compound interest case, notice that only for the first time period, okay, the interest is calculated on the original principal, which is the 100. But come the second time period, which is the second year, a new principal amount emerge, which is 110. Where does this 110 comes from? It is the original principal of 100 plus the $10 interest charged at the end of the first year. Okay? So to calculate the interest in the second year, you need to multiply the 10% interest rate on the 110, not the 100 original principal. Okay? So you follow the same method, okay, for the third year. So the third year, the new principal becomes 121, and thus the interest amount is 12 ringgit and 10 cents, so on and so forth. Okay? So at the end, the total principal plus interest becomes 161 ringgit and 5 cents, giving you the interest of 61 ringgit. Okay? Compare this with the interest of 50 ringgit in the simple interest example. Right? So that is the difference between compound interest and simple interest. Okay. Now to begin with, okay, we start off with the future value calculation for the compound interest, the single amount compound interest. Now, my approach is to use a formula. Okay. Why formula? Because it is much more practical and easier for you to calculate. You don't need tables. You don't need a financial calculator. All you need is a decent scientific calculator. So the basic formula, okay, which I always use in my class, okay, is this. This is the magic formula, okay, which I always use. Okay. FV stands for future value. N denotes the interest, the time period. Okay. Later we will delve on this. P is the principal amount. Later we will call this the present value. Okay. And bracket. Inside the bracket we have 1 plus J divided by M. Okay. And all together, okay, this term in the bracket, okay, you have to make it to the power of T times M. Now let's look at each and every one of these variables. Okay. What is J, what is M, and what is T. Okay. The FV is the future value at the end of the N periods. Okay. Now, P, as I mentioned just now, is the principal amount at the beginning. Okay. And I, okay, is the periodic interest rate. Okay. And notice that, okay, here, I here is J divided by M. Okay. What is I? Okay. I is the periodic interest rate, and what it is calculated as J divided by M, okay, whereby N, which is to the power of N outside the bracket, okay, is the interest periods, and it is T multiplied by M. Okay. Now J is the nominal or the stated interest rate, and we can also call it the quoted rate. Say for example, you have a brochure, okay, of a product, banking product for example, and they offer a certain investment, okay, or a certain product with say 3.5% interest rate. That 3.5% stated there in the brochure, okay, or quoted there in the brochure, is what we call the nominal. That is our J. Okay, that is our J. Whereby M is the frequency of compounding in a year. Okay. Now, money or interest, right, can be compounded either annually, which is once a year, semi-annually, okay, twice a year, where our M becomes 2. It can also be quarterly, 4 times a year, or monthly. And now our M becomes 12. What does it mean that money is compounded, okay, with the different compounding frequency in a year? What it means is that you calculate the interest, the respective interest amount, okay, at that particular period. Say for example, annually. So the money will sit or rest in the bank, for example, for a year until, okay, interest is charged or calculated. If semi-annually, then you do it twice a year. Okay? You put your money at say the beginning of January, and come end of the 6th month, after 6 months, then only you will calculate the interest. Okay? Similarly for quarterly compounding, you do it 4 times a year. So it means every 3 months. And if it is monthly, you do it every month. So your T is the time period in years. Okay? Again, always in years. So if it is 6 months loan, T becomes 0.5. It is a 3 months loan, it becomes 0.25. If it is 18 months, it becomes 1.5 years, so on and so forth. Okay. Now let's just apply this formula. We start off with basic, easy examples first, right? Before we move on. Now, what is the future value of $1,000 after 5 years if the interest rate is 5% compounded? Okay, we look at 4 scenarios. We start off with annual compounding first. Okay. So applying the formula of FV equals to P in the bracket 1 plus, remember your I here is J divided by M to the power of N, where N is T times M. Okay, always refer back to this formula. Okay, make sure it becomes handy to you, right? At the beginning, you may find this tedious, but after a while, it becomes automatic. Okay, trust me. Now with this annual compounding, you just plug in the figure. P is 1,000. Okay, your J is 5%. Your M is 1. Okay, your T is your N is T times M. So since T is 5 years and M is 1, so your N becomes 5. So to the power of 5. So basically, it is 1,000 multiplied by 1.05 to the power of 5. Now using your scientific calculator, okay, you need to know how to operate your calculator. You can check the manual, but it is not that difficult. You just have to know how to operate it, say to the power of. So you click on the V, okay, the inverse V button in your calculator, and make sure that you do it in one row. Okay, 1,000 times 1.05 to the power of 5. So it becomes 1276.28. Moving on, what if it is semi-annual compounding, okay, where interest is compounded twice a year? So now your M becomes 2. Okay, so the figure in the bracket here, J divided by M, becomes 0.05 divided by 2, and your T outside here, okay, in the power of there, becomes 5 times 2. Okay, so 0.05 divided by 2 is 0.025, and 5 times 2 is 10, right? So if it is simple, you still can do it, in one go. But if it becomes more complicated later, you need to calculate inside the bracket first, plus 1, okay, then only you multiply, or you will make to the power of, okay, n outside there. So in this case, it becomes 1000 times 1.025 to the power of 10, okay, and it becomes 1280.09. Notice that it increases a little bit, okay, compared to the annual compounding earlier in number 1, okay. And if you do the same for quarterly, now m becomes 4, okay. So the j here 0.05 divided by 4, your n up there it's 5 times 4, okay. So it becomes 1000 times 1.0125 to the power of 20. It becomes 1282.04. And for monthly, now m becomes 12. Your future value becomes 1283.36. Okay. Notice that it increases. Okay. It increases quite substantially at first, but later on it becomes marginally. Okay. From semi-annual to quarterly until monthly. Okay. So I think it is not that difficult. You should get the hang of it quickly and easily. Now let's look at another example. Right. Now in this case, imagine if you have invested 10,000 in an account 7 years ago, okay, and it offers a rate of return of 7.5% compounded monthly. Okay. What is the value of your investment today? Okay. So we can also apply this formula, future value, even though in this case you want to calculate the value, okay, of the money or the investment today, because your perspective now is that you go back 7 years ago, so the focal point becomes 7 years ago. That was the starting point, and you look to the front 7 years from then, okay, it becomes the future value of that particular investment, right? So in this case, we still use the same formula, okay, P times 1 plus I to the power of n, okay. So in this case, it becomes 10,000 times 1 plus 0.075, that is your stated interest rate. It's just that in this case, it is called rate of return, which is actually the interest rate, your I, okay? Your J, okay? Divided by M. M is 12. Why? Because it is compounded monthly here, okay? And to the power of why 7 times 12? Because T, the number of years, is 7 years, and M, the frequency of compounding, is monthly, i.e. 12. Okay, so 7 times 12, okay, which is 84, right? So you get $16,876.99. So compare this with your initial investment of 10,000. So the difference is basically the interest amount. We call this the compound interest amount. So let's say you are interested at, okay, in that case, what is my annual rate of return? It's very easy. The N value, which is $16,876.99, you minus it with the initial investment of 10,000, that gives you 6,876.99. Okay, and if you divide it, okay, with your initial investment, which is 10,000, that gives you 0.6877, okay, which is 68.77%. But remember, this is over the period of 7 years. So you have to divide by 7 to give you an annual rate of return of 9.82%. Compare this with the nominal or the stated rate of return initially, which is 7.5%. Okay, so effectively you get 9.82. Okay, why is the difference, and why this is larger than the stated or the quoted interest rate? This is due to the effect of compounding. Okay, due to the effect of compounding, so you will get 9.82% over and above the quoted or the stated rate of the investment of 7.5%. Okay, so that is for the future value.